Okay, we almost got through our list of exceptions here from the D borrowing from the S. The last one we had was gold, which we actually did for homework. It's or practice questions. So we know that it should be, if it followed Aufbau's diagram, it should be noble gas, kernel is Xeon, and then 6s2, 4f14, 5d9. And so it goes to Xeon 6s1, 4f14, 5d10. Now, if we were in school, I would say to you that I would not expect you to recognize or know the exceptions of the exceptions, but I would expect you to recognize the ones that are the predictable exceptions. Sorry, my laptop cord. So the ones that are going from like 3D4 to 3D5, so like chromium I would expect you to recognize. Copper that's going from 3D9 to 3D10 I'd expect you to recognize. I wouldn't expect you to recognize one going from 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. I definitely would want you to recognize the one that steals the two of them, palladium. Silver going from a 9 to a 10 again. Platinum, probably not, but gold definitely. Okay, so I would expect you to recognize the ones that aren't exceptions of the exceptions. Now, I'd love to tell you that that's all of them, but a similar thing occurs when they're filling the d orbitals and the f orbitals. Okay, so borrowing happens between the d and the f as well. And so when we're getting into the transition elements. So the first exception here is lithium. It's Z equals 57. And what it should be, if we were to write it out, its nearest noble gas is Xeon. And it should be 6s2, 4f1. Now remember, F has 14 spots for electrons. So there's this one little electron running around in a place that could hold 14. And so D, being the gracious dude that D is, he says, oh, that little electron, he's like all lonely and everything in that big, huge place. Let me take him for you. So it's always the D that's doing the borrowing. Okay, so the F doesn't borrow from the S. This becomes Xeon 6s2, 5d1. It is more stable if there is only one in the D as opposed to one in the F, okay? And that would be because the D has a tinier space. Okay, the next one is gadolinium. It's Z equals 64. Again, it's going to be Xeon as its nearest noble gas. And it should be 6s2, 4f8. Now remember, F can hold up to 14, so 8 is 1 over half. And so again, D, out of the kindness of his heart, steps up and says, let me take that one off your hands so that you can be half full. So it goes to 4f7, 5d1. Okay? So because the 4f7 would be half full and therefore more stable than having 1 over. Actinium, 89, nearest noble gas is going to be radon, Rn. And then it'll be, so it's the next gas up, so it'll be 7s2, and then again 5f1, and again D steps in. So it becomes Rn 7s2, 6d1. So that there's only 1 in the D as opposed to 1 in the F. All right, thorium, that's an R there. TH, Z equals 90, so 1 up from the previous one. So 7s2, 5f2. And D has more guts than the earlier ones. This becomes Rn 7s2, 6d2. The F disappears and both go to the D. Protactinium, 91. Again, one more, so Rn 7s2, I mean one more than the one we just did, 5f3. Okay, and what does it become? Guesses. Rn 7s2, I was double checking it before I wrote it down, 5f2, 61. So D goes back to only taking one here. Okay, uranium. Uranium is we're gonna talk about it a lot when we start nuclear in a day or two. Whoops, the U does not go there. Uranium is 92, so again, its nearest noble gas is radon. It's one more than the one above, so 7s2, 5f4. Our good friend, good buddy, D comes over, and it becomes Rn 7s2, 5f3, 61. I think like D just likes to have one, even though it's not necessarily helping F at all. Neptunium, one more than uranium. So again, Rn 7s2, 5f5, and it becomes Rn 7s2, 5, I lost the 5, 5f4, 61. And the last one is curium, named after Marie Curie, Marie and Pierre perhaps, but definitely Marie. It's 96, so again, its nearest noble gas is Rn. It's 3 more than the one above, so 7s2, 5f8. 8 is 1 over half full. And so it becomes 7s2, 5f7, 61. Okay? Now, as we go on and discover more elements, I'm sure there'll be more exceptions. But so it goes to, if the F is close to empty, then the D will take it. Or if the F is close to half full, just a little bit over half full, the D will take it. So it's taking ones from the F. So again, I wouldn't expect you to recognize the exceptions of the exceptions, but lithium obeys, gadolinium obeys, actinium. This one takes both, so thorium. Protactinium, I wouldn't expect you to recognize. Uranium, I'm going to say, if we were in school, I would say yes, just because we're working with it in the next unit. Neptunium, no, but curium, yes, because it's not an exception. Now, one other neat little thing, and that is this whole idea of the Fs, or the subshells being full, is more stable when they're full or half full, explains a lot how come some ions are more stable than others. For example, I need a periodic table. Like manganese, which is 25. So Mn said equals, I said 25, but I'm just going to double check it. So it'd be 1s2, 2s2, 2p6, that's 10, 3s2, 3p6, 4s2, that's 20. And then we go to 3d5. I think that's 25. 1, 2, 3, 4, 5. And this should be fairly stable in the sense that it's half full. The most common ion of this is M2 positive. Because the D's don't want to give anything away, it's the S's, the 2 in the 4s that disappears. And I need to go back to, where's my sheet? What's the silver ion? Silver is +1. It gives away this S5, this 5s1. Okay, so lots of times, copper, I don't know where copper is, always, right? It also can be a +1. So lots of times, the ions that are formed are because of the exceptions or just straight because of Aufbau's diagram.